Hello, this is Kiran Kamble again, and today I'm going to talk about chapter 4 from the textbook that discusses various quasi-experimental designs. This will be in two parts again, so this is part 1. Let's start. So, we all know that control groups are very important to reduce a lot of threats to validity, as we've seen in earlier chapters. However, there are examples of studies where there are no control groups are used and which still show, albeit weakly, but some sort of causal relationship. Let's see one such study shown in the textbook on page 103. Now, this study refers to actually a program which was conducted in 1966 in Canada uh, to screen and treat infants born with phenylketonuria, PKU, to prevent future PKU based retardation that occurs in these infants. So after the program implementation, when the evaluation is done, it was found that 44 infants born with PKU showed no retardation, while three and two of those were missed out of the program, so were not included in the program. So actually one were showed some sort of showed severe retardation. So it was deduced that the program was effective, the intervention was effective in reducing or eliminating the possibility of retardation in children, infants born with PKU. This is one of the rare examples. It's not the norm actually, without control having such results. So, what are the benefits of having a quasi-experimental design without a control group or a pretest? So the benefits are the first one is that it allows for directing the resources to be allocated to match the study focus. So studies have different focus. Some have construct validity as the focus. Some have external validity generalization as the focus. So having this flexibility of not having a control group or pretest can give you the focus of having you know very specific resource allocations. The second utility is to meet the constraints that are typically faced in the study. Means having a theoretical randomized experiment is always possible, but in reality, it's not always possible due to budgetary constraints, ethical constraints. Even having control group is not possible everywhere, and administration constraints. And the third benefit is to comply with the logistical constraints which relate to the earlier constraints that we talked, especially when it is seen that the evaluation design of the study or the program is not been operationalized before designing the program. So in such cases, it is beneficial to have such design without control and uh, without pretest. Now, moving on, what are the three closely related principles to address three basic requirements for all causal relationships in a quasi experimental design? Now, we've seen in earlier chapters the fundamentals of a causal relationship as proposed by John Stuart Mill are cause before the effect, covariance between the cause and the effect, and implausibility of alternate explanations for the effect. Now, randomized experiments and quasi-experiments both can, take care of the first tenet that we saw, that cause before the effect, by manipulating the cause. That can be done. Uh, as far as tenet 2 covariance is concerned, that can also be taken care of through statistical analysis. Now, the randomized experiments, or the experiments as we call them, can take care of the third tenet, that is uh, the implausibility of alternate explanations through randomization. But how does quasi-experiment designs do it? Should do it. And the textbook mentions three principles for doing that. The first principle is identification and study of plausible threats to internal validity. So, understanding such threats to internal validity will help, and studying them will help identify the likelihood of cause effect covariation. The second principle the book talks about is the importance of control by design. So, there are two types of controls. One is design modification, one is statistical control. So, by statistical controls, confounders can be removed and adjusted for. But design modifications is important because it can eliminate threats to internal validity. Although both these controls are important, design control should be the main focus because it helps, it is done before the study, it is much more sustainable, and it reduces the need for the statistical control later after the study, which is done after the study. The third principle is coherent pattern matching, which is an esoteric approach, which means identifying a very complex pathway for between the cause and the effect so that this complexity of the pathway cannot be mimicked or cannot be explained by alternate plausible explanations. So one such example of this kind of complex pathway explanation is one of enumeration is non-equivalent dependent variable design, NEDV design, which will be discussed later. However, it has been noted that none of these principles provide the finesse of causal inferencing that is provided in a randomized experimentation, of course. But these are practical and realistic. Uh, However, despite using these principles, the quasi-experimental designs or studies based on these designs have to be extra cautious about alternate explanations of any causality. Let's move on to the next one. So let's look at what one group post-test only with multiple substantive post-test designs look like. Now, one group post-test only design entails only one group in the study, and as the box indicates, there is a treatment given and one measurement outcome measurement is done, that is O1. That's it. There is no pretest and no control, of course. Now, this is considered a very weak in terms of causal inferencing, but the strength of the causal inferencing also depends on the background knowledge about the outcome, the large magnitude of the effect, and third, the information of all alternate explanations that we have about the effect. So if these three are uh, available, then a causal inference can be made. Again, repeating, it will be weak, but it can be made. So for example, um, there is a study where students at junior level high school are given a course on calculus, and then after the course their knowledge about calculus is tested or measured, and there is an increase in the knowledge of the calculus that they have, and this is usually then attributed to the course that was rendered to them, because any alternate plausible explanation will be very weak, because typically students at this age or children at this age are not exposed to calculus on TV, at home, or on radio, or anywhere else. So this course would be the only reason, plausible reason, for them to have learned about calculus. So these are very rare examples and rare cases, but it can happen. Now, what are the validity threats to this one group post-test only design? All internal validity threats actually apply except the ambiguous temporal precedence threat. So threats like selection, history, maturation, regression, attrition, and instrumentation, all these internal validity threats apply to this design. So what are the remedies to take care or to counter these threats? So comprehensive knowledge about the outcome, as we saw before, understanding the magnitude of the outcome or the effect, and to understand or to have knowledge about all the plausible explanations for the effect is very important. So these can be translated into specific remedy solutions like pattern matching, coherence, and multiple post tests. Now, using multiple substantive post tests, can these validity threats be reduced? Let's see. So, multiple substantive post tests work retrospectively as against a typical prospective quasi-experimental design approach. So in this approach, multiple post-treatment constructs are assessed with known pathways of the possible causes, much like solving a murder mystery, where you see a lot of clues and then you work backwards looking at the clues to identify the culprit or the cause or the reason for the murder. So this is how it is done typically in a multiple substantive post test. The approach is retrospective. This is proposed or understood to take care of the threats that we talked about earlier. But despite that, there will be some remaining issues. So what are these? Now, multiple post tests will typically lead to type 1 error. That is, the possibility, the type 1 error would be, of course, rejection of a true null hypothesis. So, finding an effect where there is none is what would typically happen in a multiple post test scenario. Let's move on to the next. So, one group pre-test and post-test design. Now, this design entails uh, a single pre-test of the outcome construct followed by the treatment, which is followed by a single post-test of the same outcome construct. So it's simple, one group pre-test and one post-test. So adding a pre-test, which was not there in the earlier design that we saw, provides information about the counterfactual, which is weak, but still it does provide some indication to the counterfactual. That is what, as we know, studied in earlier chapters, counterfactual is what would have been without the treatment. So with the treatment, we have an effect of the cause from the cause, but without a treatment, what would have been with that particular variable? So that is the counterfactual. So that we get a small weak indication of that counterfactual through by adding a pretest. Now, if this design is done using same units, it is called as within participant design. And when different units are used, it is called between participant design. Now, example of one group pre and post test design is a campaign, as explained in the book, is a campaign to reduce dog litter that was done in Chicago using educational material and providing waste disposal plastic bags. It showed reduction in the dog litter, which albeit had a weak attribution to the campaign that was done, but there were very weak other plausible alternate explanations as well. So there could be a causal inference made there. A better example in the again given in the book is the lead reduction campaign that was undertaken in Baltimore in the urban housing units, which included again education, but also physical intervention, structural changes in the units. And there it was seen the good dramatic reduction in the lead content in the urban housing units. And this was basically due to the physical intervention that was undertaken. So, what are the validity threats in this design? This design is supposed to be plagued with several threats, as was proved under in the late program as described in the book with evidence. So internal validity threats such as maturation, history, testing, and attrition were seen. Statistical conclusion validity threats due to low sample size and resulting in low power were seen. And additionally, construct validity threats were also seen in this particular study due to biases from the administrators or those who were doing the late interventions. So, what are the remedies for these threats? The remedies are to ensure cohesiveness of outcomes, short interval between the pre and post test, and adding more design elements. Those are the remedies for this kind of this kind of threats. Now, using a double pretest uh, solution, can these threats be reduced? So instead of one pretest, we add another one to it. Now, such double pretests would certainly reduce the threats of maturation and regression by teasing out the biases that may occur between the pre-test just before the treatment and the post-test after the treatment. So this additional pre-test helps tease out those maturation and regression threats that may occur. Now, can these threats be reduced using a non-equivalent dependent variable design, that is NEDV design, as is known? Now, NEDV design entails adding a non-equivalent dependent variable to the experiment, which does not undergo the treatment, which is not, the treatment is not rendered to that particular variable as in the box. So you have O1, which is render the treatment, and then the outcome measure of O1 is done after the treatment. There is a pre-test and there is a post-test. And there is another non-equivalent dependent variable which is added, which is O2, but it is not given any treatment, and then it is measured again uh, at the same time interval as the post-test for O1. Now, what this shows is, though this is non-equivalent dependent variable, there are some similarities between this variable and also between O2 and O1. So any change in O2 will be due to other factors than the treatment, as this was not given, the treatment was not given to O2. So this can be compared as plausible alternate explanations. This can be considered as plausible alternate explanations for O1, and eliminating those or adjusting for those will then help us determine whether the treatment was responsible for the outcome measurement differences in O1. So that is what a non-equivalent dependent variable design is. Now, with both these double pretest and non-NEDV designs, what are the remaining issues? There would be some, because all the threads cannot be eliminated. So history in its operational form, statistical regression would be the thread still remaining for the NEDV design, and non-linear trend maturation would be the thread that will still persist for the double pretest. Hope that was clear. Let's move on to the next question. So the last design that we're going to see for this section is the removed treatment design, and we'll also study the figure 4.1 in the book. So what is this removed treatment design? So remote treatment design entails adding a third post-test to the one group pre-test post-test design and then removing the treatment at a interval where it was supposed to be administered, and they taking a third post test or the fourth measurement actually, starting from the pre-test, and that is O3. So we have three post tests and uh, one pre-test. So that is the remove, but between the last two post-test, the treatment is removed. So this is what the removed treatment design is. Now, example is a case that I came across at in an NIH article talking about how the costs of a pharmacy in a pharmacy, the pharmacy product cost were reduced after institutionalization of an order entry system, online order entry system, which entailed that customers go online, place an order, and then the orders were filled in the pharmacy, which reduced a lot of labor, which reduced time, so thereby leading to reduced cost of the products. But after a certain interval, when the same system, the online order entry system, was removed, disabled, it was seen that there was a slight increase in the cost of the pharmacy products. So that shows, and this is a typical, remote treatment design, uh, or can be equated to a remote treatment design, and where we can see that there's due to this rise in the price, we can attribute the initial decrease in the price to the system being put in place. Let us further understand this with the figure 4.1 from the textbook, which is copied here. Apologies for the poor quality of the picture. Uh, so as you can see in the figure, the x-axis is the sequence of the four outcome measurements. One is pre-test, O1, and three post-tests, O2, O3, and O4. The y-axis shows the outcomes measurement performance level from worse to better. So O1 is somewhere between worse and better, more towards the worse, I can say. And X is the treatment. So when the treatment is given, you see that there is an improvement in the outcome as seen in O2, which is towards the better. Now, as we move along the x-axis, the effect of the treatment is expected to wear off, which is natural reduction in the effect. And that will lead to the O3 measurement, which will be lesser than on the y-axis than O2 because of the wearing off effect. Now, the next part of the hypothesis is where the treatment was supposed to be given, the next X that we say with a which is crossed off. Uh, because that treatment is not given, the anticipated effect is the O4 level that is seen as the interpretable outcome. So that will be much less reduced than O3 because no treatment was given. So it's further the treatment effect wears off and it goes to the level that is shown as the interpretable outcome, goes towards the worse. But sometimes it may happen that the the treatment effect may persist, and in some cases depends on the treatment, depends on the type of study, and you can see an uninterpretable outcome. That is because of the persistence of the effect of the treatment, you can see the other line that goes slightly lower on the y-axis but higher than the one shown in the interpretable outcome, and that is termed as the uninterpretable outcome because one would not be able to explain. The interpretable outcome can be explained saying that, okay, the treatment effect weared off from O2 to O3 and then further went down from diminished from O3 to O4. But what happened with this uninterpretable outcome is not really clear, and that's why it is called as the uninterpretable outcome. So, what are the validity threats to this remote treatment design? So the Threats can be statistical conclusion validity uh, due to even a single outlier. So as you can see in the figure, this effect that we see, the uninterpretable outcome, can even be due to a single outlier, and that would make it difficult to reach any uh, statistical conclusion that will be valid enough. So there will be threat to statistical conclusion validity. Now, threats mimicking resentful demoralization and compensatory rivalry owing to removal of the treatment can also happen. But the most important, not a threat actually, most important aspect of this is the unethical uh, element of removing a treatment in study. Most studies or most treatments, especially clinical trials, removal of treatment will be very unethical. So, what are the remedies to counter these threats that we saw? Large sample sizes and reliability in taking the four measurements, O1, O2, O3, O4, they have to be very reliable. Consistency and a standardization in taking the measurements. Large sample sizes will help minimize the statistical conclusion validity threats that we saw. Additionally, taking the measurements at equally spaced intervals will will allow detection of any temporal spontaneous linear changes. So it has to be timed specifically at the same intervals, all the four measurements. So those would be the remedies to counter the threats that we saw for the remote treatment design. Hope those concepts were clear. So till next time, thank you.